Hello my lovely students, you are welcome to a new lesson. Today I shall be teaching you mensuration and we shall be looking at the circle. By the end of this lesson, you should be able to solve problems involving various parts of a circle. Happy viewing.
Hello my lovely students, you're welcome to a new lesson. Today I shall be teaching you mensuration and we shall be looking at the circle. From definition, mensuration is the process of measuring and or calculating lengths, areas and volumes of geometrical shapes. Also from definition, a circle is a round plane shape. A circle consists of the following parts. A circle has the center, circumference, chord, diameter, radius, arc, segment, sector, and the semicircle. Let's learn more about the circle. Let's look at some circle formulas. Number 1, the length of an arc of a circle. The formula is L for length equals theta over 360 degrees times 2 pi radius. Number 2, the perimeter of a sector. Formula is P equals theta over 360 degrees times 2 pi radius plus 2 radius. Number 3, perimeter of a segment. The formula is P equals theta over 360 degrees times 2 pi radius plus 2 radius sine theta over 2. Number 4, the formula for the area of a sector. The formula is A equals theta over 360 degrees times pi radius squared. Number 5, the formula for area of a segment. The formula is A equals theta over 360 degrees times pi radius squared minus 1 over 2 radius squared sine theta. In these formulas, theta represents the angle subtended by the arc or the sector or the segment at the center of the circle, while R represents the radius of the circle, which is half of the diameter. Please take note of these circle formulas because we are going to need them shortly for our solved examples. I hope these formulas are clear to you. Moving on, let's take some solved examples. Example 1. An arc subtends an angle of 105 degrees at the center of a circle of radius 6 centimeters. Find the length of the arc if pi is equal to 22 over 7. Can you remember the formula for the length of an arc? Let's see if you can still remember. The formula needed for the length of an arc is theta over 360 degrees times 2 pi radius. In this question, the angle is 105 degrees, which is the value for theta. Pi is 22 over 7 and the radius is 6 centimeters. Substituting these values into your formula for length of an arc, the answer to question 1 is 11 centimeters. The length of the arc in question 1 is 11 centimeters from substitution and calculation. I hope question 1 is clear to you. Looking at question 2, an arc subtends an angle of 144 degrees at the center of a circle of radius 5 centimeters. Calculate the length of the arc in terms of pi. Once again, do you still remember the formula for the length of an arc? The formula for the length of an arc remains theta over 360 degrees times 2 pi radius. In this question, the angle theta is 144 degrees. The question says, calculate in terms of pi. Calculate in terms of pi. That means that pi remains pi. Pi remains pi. Pi equals pi. The radius in question 2 is 5 centimeters. Substituting these values into your formula for length of the arc, the answer to question 2 is 4 pi centimeters. The length of the arc in question 2 in terms of pi is equal to 4 pi centimeters. Moving on to our next question, question 3. Calculate the perimeter of a sector of a circle of radius 7 centimeters. The angle of the sector being 108 degrees if pi equals 22 over 7. Here the diagram for the question. We are to calculate the perimeter of the sector. Once again, can you remember the formula for the perimeter of a sector? Let's see if you are correct. The formula needed for the perimeter of a sector is theta over 360 degrees times 2 pi radius plus 2 radius. In question 3, theta is 108 degrees, representing the angle of the sector. Pi is 22 over 7. The radius of the sector is 7 centimeters. Substituting these values into your formula for perimeter of a sector and calculating, we are going to have the perimeter of the sector being 27.2 centimeters. After substitution and calculating, the perimeter of the sector in question 3 is 27.2 centimeters. I hope question 3 is clear to you. Taking on our fourth question, a segment subtends an angle of 60 degrees at the center of a circle of radius 21 centimeters. Calculate the perimeter of the segment. We are taking pi to be equal to 22 over 7. Here the diagram for the question. We have a segment in question 4. Now, can you remember the formula for the perimeter of a segment? Let's see if you are right. The formula for the perimeter of a segment, P equals theta over 360 degrees times 2 pi radius plus 2 radius sine theta divided by 2. That is the formula needed for question 4, solving the perimeter of a segment. Substituting the values in the question, theta is 60 degrees, pi is 22 over 7, the radius of the circle is 21 centimeters. What you do here, substitute these values into your formula and calculate. At the end of your calculation, the perimeter of the segment in question 4 is 43 centimeters. The perimeter of the segment in question 4 is 43 centimeters. Ensure you substitute properly into your formula and you calculate correctly to get your correct answer. I hope question 4 is clear to you. Let's take on our fifth question. Calculate the area of a sector of a circle which subtends an angle of 45 degrees at the center of a circle of radius 14 centimeters. We'll take pi as 22/7. Here is the diagram to question 5. Can you remember the formula needed here for the area of a sector? Let's see if you are right. The formula for the area of a sector is theta over 360 degrees times pi radius squared. Theta over 360 degrees times pi radius squared. In question 5, the angle is 45 degrees representing theta. Pi is 22/7 and the radius of the circle is 14 centimeters. So as always, we substitute these values into our required formula and we calculate correctly. At the end of the calculation, the area of the sector in question 5 is 77 centimeters squared. The area of the sector in question 5 is 77 centimeters squared from substitution and calculation. I hope question 5 is clear to you. Let's take our sixth example. Calculate the area of the shaded segment of the circle shown below. We are using pi as 3.14. The diagram is represented here. Here we have a shaded segment of a circle, the radius of the circle being 10 centimeters and the angle of the segment subtended at the center of the circle is 36 degrees. Can you remember the formula for the area of a segment? Let's see if you are correct. The formula for the area of a segment is theta over 360 degrees times pi radius squared minus 1/2 radius squared sine theta. That is the formula needed to solve for the area of a segment. In question 6, the angle theta is 36 degrees, pi is 3.14, and the radius of the circle is 10 centimeters. So once again, having known this, substitute these values into your formula for area of a segment and calculate correctly. At the end of calculations, the area of the segment of the shaded segment in question 6 is 2.01 centimeters squared. The area of the shaded segment in question 6 is 2.01 centimeters squared. I hope question 6 is clear to you. Thank you very much for going through the lesson today. I want to advise that to get more information about the topic mensuration circle, please read your textbooks. Don't forget to attempt your quiz and your assignments. I hope to see you again in our next class, and until then, it is bye for now. Thank you very much.